Welcome to the last part of Chemistry Chapter 3, Metals and Non-Metals, and today we are going to learn about corrosion of metals as well as alloys, their properties and their uses. So let's start with the topic of corrosion. It's going to be a short video today, maybe half an hour or so. So let's finish this fast and understand what's there in today's video. Okay, so corrosion. See, surfaces of many metals are easily attacked when exposed to atmosphere. Why? Because in atmosphere there is water vapor basically, many gases which react with the surface of metals and form undesirable compounds on their surfaces. And greater the reactivity of a metal, higher is the position of a metal in the reactivity series, greater are the chances uh, that it will react with the components of gases present in the air. These undesirable compounds are generally oxides, and this process is called corrosion of metals. Almost all metals except the noble metals such as gold, platinum, palladium are attacked by environment. All metals except noble metals, okay? So gold, platinum, palladium are not attacked by atmospheric components. Except gold, platinum, palladium and all other noble metals, all the other metals are attacked by atmospheric conditions. In other words, almost all metals get corroded. For example, when iron is exposed to moisture for a long time, its surface acquires a brown flaky substance called rust. So rusting is a kind of corrosion. Corrosion is not rusting, but rusting is corrosion, because rusting happens only in iron. Corrosion happens in all the metals. Iron acquires a kind of corrosion which is known as rusting. Copper reacts with moist carbon dioxide in air and slowly loses its shiny brown surface and acquires green coating of basic copper carbonate in moist air. So copper reacts with moist carbon dioxide to form copper carbonate, which is green in color. Have you seen Statue of Liberty? The monument in United States of America's city, New York. If you have seen the Statue of Liberty, let me show you the picture. Statue of Liberty. Yeah. Can you see the color of Statue of Liberty? It is greenish in color. Okay. Actually, when Statue of Liberty was brought to USA, France gifted this statue to USA. When this statue was brought to USA, it was copper in color because it is made up of a alloy of copper. Okay, so its original color was uh, like like reddish brown, but it turned to greenish color because of corrosion, that is the formation of copper carbonate on the surface of copper. Silver articles become black after sometimes when exposed to air. This is because silver articles react with sulfur in the air to form coating of silver sulfide. Okay, remember, silver articles also get corroded. They turn black. Actually, this black coating is can be removed very easily by polishing silver. Okay, this black coating is due to the reaction of silver with sulfur in air to form a coating of silver sulfide. Okay, lead or stainless steel lose their luster due to corrosion. So corrosion is a process of deterioration or eating up of a metal. It's a surface phenomena. Okay, it starts from surface and then eats up the whole metal as a result of its reaction with air or water present in environment surrounding it. Okay, so this is the definition of corrosion. The corrosion causes damages to building, bridges, ships, and many other articles specially made up of iron. We know that. Unreactive metals such as gold, platinum, palladium, titanium, etc. do not corrode. That's why they are expensive. As we know, gold is yellow shining metal. It does not corrode when exposed to atmosphere, and therefore it does not tarnish and retains its luster for years, and that's why it's expensive. Therefore, gold is used for making jewelry because of its bright shiny surface and high resistance to corrosion. Platinum is also used to make jewelry. Platinum is also used to make jewelry because of its bright shiny surface and high resistance to corrosion. Okay, now let's study about rusting of iron. So corrosion of iron is known as rusting of iron. Rust is Fe2O3.XH2O, that's its chemical composition. Corrosion of copper is green coating of copper, that is basic copper carbonate, CuCO3.CuOH twice. Corrosion of silver is black coating on silver surface, that is due to silver sulfide. Let's focus on rusting of iron. Iron corrodes readily when exposed to moisture and gets covered with a brown flaky substance called rust. This is also called rusting of iron. Chemically, the rust is a hydrated iron oxide, iron 3 oxide hydrated, Fe2O3.2H2O. Rusting is an oxidation process in which iron metal is slowly oxidized by the action of air. Rusting is an oxidation process in which iron metal is slowly oxidized by the action of air in the presence of water. Therefore, rusting of iron takes place under the following conditions: presence of air or oxygen and presence of water or moisture. So both these conditions are absolutely necessary for rusting of iron to take place. Otherwise, iron will not rust, and we'll do an activity based on this. It has been observed It has been observed that presence of impurities in the metal speeds up rusting process. Therefore, pure iron does not rust. I doubt that. Pure iron do rust, but it takes a lot of time. The presence of electrolytes in water also speeds up the process of rusting. Therefore, rusting of iron in water containing sodium chloride occurs quicker than in distilled water. So, if the water is salty, it contains dissolved salts in it, then rusting process will be quicker. Therefore, the ships which sail in seas rust faster than the ships which sail in river water. The position of metal in the electrochemical series determine the extent of corrosion. More the reactivity of metal, more will be the possibility of the metal getting corroded. Let's perform an experiment. So in this experiment, we have to show that rusting of iron requires both air and water. So as you can see, there are three test tubes. In the first test tube, iron nail is kept and it is dipped in water. Nothing else is there. Nothing else means, yeah, of course, air is there and water is there, and iron is dipped in water. In the second test tube, boiled or distilled water is there, and over in that water, iron nail is completely submerged, and on the layer on this boiled or you can say distilled water, a layer of oil is kept. Okay, and this test tube is tightly covered with rubber cork. In the third test tube, there is dry air and anhydrous calcium chloride, which has the property of absorbing moisture from air, so it keeps the air dry. Okay, there is no water, there is just air, and which is also dry. So the observation in this three test tube after a few days will be that the first test tube containing the iron nail will show the rusted iron. First iron nail will be rusted. Okay, but the second and third test tube will not show rusted iron nail. Why? Because in the second test tube, water was boiled and distilled water. It did not contain any dissolved substance or gases, nor any gases could dissolve in it, because above it there was a layer of oil, and gases, they cannot get absorbed in oil, and so they cannot pass through water and get absorbed in it. So only water, in the presence of only boiled distilled water, iron nail does not get rusted. But what about in the third test tube? There is air, but there is no moisture. Whatever moisture was present, it was absorbed by anhydrous calcium chloride, which is a dehydrating substance, or deliquescent substance they call it. Okay, so it absorbs all the moisture present in the test tube, and the iron nail kept in the third test tube does not get rusted, but only in the first test tube the iron nail gets rusted. So it shows that both moisture, that is water content, as well as oxygen are necessary for iron to get rusted. Either one of them will not be able to produce rust in iron. Okay, how to prevent rusting? And there are many processes. Basically, what you have to do is you have to prevent the attacking components from air to come in contact with the surface of any metal. That is the best way of preventing rusting. But how to create a barrier for these elements to stop reaching the surface of any metal? Okay, the first uh, method is coating the metal surface with a thin layer of paint, varnish, or grease. Many vehicles, such as cycle, motor, cars made from iron sheet, are protected from rusting by paints. Okay, varnish is also such kind of a coating which prevents any outer, you can say, attacking agents to come in contact with iron surface or metal surface. Iron is protected from rusting by coating it with a thin layer of another metal which is more reactive than iron. For example, zinc. Zinc is more reactive than iron. So zinc is commonly used for covering iron surfaces. And the process of covering iron with zinc is called galvanization. So galvanization is a process of covering iron with zinc. Galvanized iron sheets maintain their shine. Okay, iron is also coated with other metals such as tin, known as tin coating. So either zinc or tin, which are more reactive than iron, are coated on the surface of iron, and these metals which are coated on the surface of iron gets rusted, and iron do not get rusted in this process. The water supply pipelines are generally galvanized. Galvanization is covering iron with zinc coating. So water supply pipeline are generally galvanized. Okay. The iron pipes which are in contact with water, such as groundwater pipes, are protected from rusting by connecting these with more active metals like magnesium or zinc, as I told you. To decrease rusting of iron, certain anti-rust solutions are used. For example, solutions of alkaline phosphates are used as anti-rust solutions. So they just put a coating of these anti-rust solutions and the metals do not get rusted. And you can use alloying. Some metals, when alloyed with some other metals, they become more resistant to corrosion. For example, when iron is alloyed with chromium and nickel to form stainless steel, it will become resistant to corrosion and it does not rust at all. It rusts, but it depends on the quality of the iron. Mostly the utensils used in your homes, you use them, stainless steel utensils, and you see that they don't get rusted so quickly, right? It may be noted that corrosion of metals is sometimes an advantage because it prevents the metal underneath from further damage. For example, aluminium is the best example for this. Okay, uh, aluminium forms a protective layer which protects aluminium from further damage. That is aluminium oxide. So when freshly cut aluminium, which is very shiny, like just like silver, it comes in contact with atmosphere, it very quickly becomes dull. So this dullness is due to the covering of the outer layer of iron by aluminium oxide, and this aluminium oxide is highly impermeable. Impermeable means atmospheric components which can rust or which can corrode, I'm sorry, not rust, which can corrode aluminium, cannot penetrate this very strong layer. Even acids cannot penetrate them. So these layers are very protective for the rest of the aluminum. That's why aluminum becomes dull due to the coating of aluminum oxide on them, which is a natural process. So, however, corrosion of iron is a serious problem. Every year, enormous amount of money is spent to replace damaged iron and steel structures to protect them from serious damages, just like bridges or buildings. You have to keep the exposed metallic parts of iron of these structures. You have to keep them protected. Otherwise, if they get rusted, then there will be huge damages. Okay, so the next topic is alloys and amalgams. So, what is an alloy? See, alloying is a very good method for improving the properties of metal. Alloying is what? When two metals are melted and mixed in a specific proportion. Yeah, the proportion can be more or less, but yeah, it is somewhat we have an idea that this should be the percentage of this particular metal in this particular alloy. Okay, so we can, if we can alloy the metals together, then their properties will improve to a greater extent, and we can get desired properties by this method. Wonder of ancient Indian metallurgy. The iron pillar near Qutub Minar at Delhi. I don't know how many of you seen them, but I'll show you the picture. It was made around 400 BC by iron workers of India. They had developed a process which prevented wrought iron from rusting. Okay, wrought iron is a type of iron. Wrought iron is also used for making furnitures. The beds are made up of wrought iron beds. Okay, so this wrought iron, uh, which has been, the wrought iron which has been used for making this iron pillar is was made around 400 BC. So it's approximately 2,500 years back. 2,500 years old pillar, but it has not rusted. It is 8-meter high and it weighs around 6,000 kilograms. It is not a wonder that a pillar still stands in a pristine condition more than 2,000 years after it was manufactured, right? So they had developed a process which prevented wrought iron from rusting. Amazing. Alloys and amalgams. Let's talk about alloys and amalgams now in detail. Iron is most widely used metal, but it is never used in the pure form. This is because pure iron is very soft and stretches easily when hot. But when it is mixed with small amount of carbon, about 0.05%, it becomes very hard and strong. The new form of iron is called steel. The strength and other properties of steel depends upon the percentage of carbon in it. This means that we can change the properties of a metal by mixing with some other metal or non-metal. This mixture is called alloy. So in alloy, not only two metals are mixed, but a metal and a non-metals are also mixed. So this is the definition of alloy. An alloy is a homogeneous mixture of two or more metals, or a metal and a non-metal. Similarly, when iron is mixed with other metals such as nickel and chromium, we get an alloy called stainless steel. When iron is mixed with other metals such as nickel and chromium, we get an alloy called stainless steel. This is strong, hard, and does not rust at all. Thus, if iron is mixed with some other substances, its properties are changed. In fact, the properties of any metal can be changed by mixing it with some other metals or non-metals by forming alloys. We also come across brass articles. Brass is an alloy of copper and zinc. An alloy is generally prepared by first melting the main metal and then dissolving the other elements in it in a definite proportion, metals or non-metals. Okay, it is then cooled to room temperature so that the mixture gets solidified. The solid mixture is an alloy. Objects of alloy making. Actually objective होना चाहिए यहाँ पे. Objective of alloy making. Why alloy is being made? Alloys are generally prepared to have certain specific properties which are not possessed by the constituent metals. The main objective of alloy making are: number one, to increase resistance to corrosion. Corrosion is a big problem. To increase resistance to corrosion, alloys are made. For example, stainless steel is prepared which has more resistance to corrosion than iron. To modify chemical reactivity. The chemical reactivity of sodium is decreased by making an alloy with mercury, which is known as sodium amalgam, right? So sodium is highly reactive. We cannot use sodium as it is in its raw form. So sodium is alloyed with mercury. Sodium is mixed with mercury to form its alloy, which is known as sodium amalgam. Actually, any metal when mixed with mercury, we can get its amalgam. Amalgam means a mixture of any metal with mercury. To increase the hardness, for example, stainless steel. It is an alloy of iron and carbon. Actually, just steel. Stainless steel is an alloy of iron, carbon, steel, and nickel. No, sorry, chromium and nickel. So, steel is just an alloy of iron and carbon, and which is harder than iron. To increase tensile strength, magnesium. Remember the word magnesium. It is an alloy of magnesium. So, magnesium gets mag from magnesium, and aluminium, it gets this nalium from aluminium. Okay, so this magnesium has greater tensile strength as compared to aluminium and magnesium. Tensile strength means it can bear a heavy load on it. To produce good casting, okay, metals are generally used for making casts. In casts, basically, you can you can make objects of different shapes by pouring its you can say hot molten objects into this cast. You can make objects of different shapes of desired material. So type metal is an alloy. Type metal is an alloy of lead, tin, and mercury, which can be used to produce good casting. To lower the melting point, for example, solder. Remember this metal, solder, not soldier. Okay, solder is an alloy of lead and tin. 50% lead, 50% tin. It has low melting point and it is used for welding electrical wires together. In electrical circuits, they use soldering for joining some components of the electric circuits. So solder is that alloy. Amalgam. Amalgam are special class of alloys. These are special class of alloys in which one of the constituent metal is mercury, always. So amalgams are homogeneous mixtures of a metal and mercury, any metal with mercury. For example, sodium amalgam. It is sodium plus mercury. These are formed by treating metals such as sodium, zinc, tin, gold, etc. with mercury. Different amalgams are prepared depending upon their uses. For example, sodium amalgam is used to decrease the chemical reactivity of sodium metal. It is also used as a good reducing agent. Tin amalgam. Tin amalgam is used for silvering cheap mirrors. The process of amalgamation is used for extraction of metals like gold or silver from their native ores. So amalgamation is a process which is also used for extraction of gold or silver metals. Now you must be wondering that gold and silver are found in their original state, you can say native form. Yeah, but still it has to be purified to get 100% of gold. So amalgamation is one of the process which is used for that purpose. Some important alloys. Steel, number one. It is an alloy of iron and carbon containing 0.1 to 1.5% carbon. So the constituent of steel are iron and carbon. The constituent of stainless steel are iron, nickel, chromium, and carbon. Remember that. It is different from steel. Steel is not very shiny. Stainless steel is very shiny. Pure iron is not very hard and strong. It is brittle, and to increase its strength, to use it for structural purposes, we add iron to it. Hence, most of the molten pig iron. obtained from blast furnace, that is a pure iron. Pig iron is a pure iron. It is converted into steel. So steel is a very hard and tough and strong substance. It is used for making rails, screw girders, bridges, railway lines, etc. Steel can also be used for the construction of buildings, vehicles, ships, etc. So these are the types of ions, commercial varieties of ions. They differ in their carbon contents. So we have cast iron or pig iron, which has 2 to 4.5% of carbon. We have wrought iron up to 0.5% carbon. We have steel, which has 0.1 to 1.5% of carbon. Steel comes in between cast iron and wrought iron and shows intermediate properties. Wrought iron is the purest form of iron, while cast iron is the least pure form of iron. Remember, steel is manufactured from cast iron by reducing its carbon content from about 5% to between 0.1 to 1.5% depending upon the quality of steel to be prepared. पूरा information है, मैं तुम्हारे लिए read कर रहा हूँ, but after all you have to remember all these points. Okay, so here we have some important alloys of steel. First is stainless steel. It has got 73% iron, 18% chromium, and 8% nickel. It does not contain carbon. Okay, its properties are it does not rust. It is used for making utensils, cycle, automobile parts, cutlery, razor blades, etc. Then there is nickel steel. 96 to 98% of iron, nickel is 2 to 4%. It is hard, elastic, and rust proof. It is used for making cables, automobiles, and aeroplane parts, armor plates, etc., gears, etc. Invar, 64% iron, 36% nickel. It has low expansion on heating. It is used for meter scales, measuring instrument, clock pendulums, etc. Chrome steel. It has got 98% iron, chromium 1.5 to 2%. It has got very high tensile strength and is used for making cutting tools such as files and cutlery. Tungsten steel, 94% iron, and tungsten is 5%, and carbon is 1% approximately. Very hard and resistant to corrosion. It is used for high speed cutting tools, springs, etc. Alnico, aluminium, nickel, and cobalt, and with iron. Iron, aluminium, nickel, cobalt. It is strongly magnetic. It is used for making permanent powerful magnet. Manganese steel, 86% iron, 13% manganese, and we have some 1% of carbon also. Extremely hard, resistant to wear and tear. It is used for making rock crushers, burglar proof safes, railroad tracks, etc. So depending upon the uses and the properties, the alloys of iron are made over here. Alloy steels. Ordinary steel is affected by the action of air, acids, alkalis, and other chemicals. However, when varying amount of other elements are added to steel, its properties are modified. These are called alloy steels. The steel obtained by the addition of some other elements such as chromium, vanadium, titanium, molybdenum, manganese, cobalt, nickel, carbon steel, or nickel to carbon steel are called alloy steels. The alloying elements modify the properties of steel. For example, stainless steel is an alloy of iron with chromium and nickel in it. It is hard and strong and does not rust on exposure to humid air. Since stainless steel resists rusting, it is used for making cooking utensils. क्योंकि कुकिंग में तो यार पानी तो यूज करना ही पड़ेगा, तो एकदम प्रॉपर आयन के सब्सटेंस तुम यूज नहीं कर सकते. Knives, scissors, tools, surgical instruments, equipments for food processing industries, dairy industries. Some common alloy steels and their important features are given in the table 6. Table 6, I think यही है. Alloys of aluminium. Okay, aluminium बहुत light metal होता है, but not very strong. ठीक है, therefore it is alloyed with some strong metals to make it strong. एक है ड्यूराल्यूमिन. ड्यूराल्यूमिन में 0.5% मैग्नीशियम, 95% एल्यूमिनियम, 4% कॉपर, 0.5% मैंगनीज होता है. एल्यूमिनियम, कॉपर, मैग्नीशियम, मैंगनीज. ठीक है, It is very strong, much more stronger than pure aluminium. Since duralumin is light yet strong, it is used for making bodies of aircrafts, helicopters, jets, kitchenware like pressure cooker. Duralumin is resistant to seawater corrosion and therefore it is used for making bodies of ships, and it is also known as duralium. Magnesium, it has got 95% aluminium and 5% magnesium, light and hard, more hard than pure aluminium, so it is used for making light instruments like balance beams, pressure cooker, etc. Alnico, aluminium, iron, nickel, cobalt. Uh, it is highly magnetic in nature, can be used for making powerful magnets. Then there are alloys of copper. Two very famous alloys of copper are brass and bronze. Right? Brass, it has got to 80% copper, 20% zinc, more malleable than copper. Brass, more stronger than copper. It is used for making cooking utensils, condenser sheets, pipes, hardware, nuts, bolts, screws, wires, tubes, scientific instruments, springs, ornaments, etc. Bronze, it is a alloy of copper and tin, 90% copper, 10% tin. Bronze is very tough and highly resistant to corrosion. It is used for making utensils, statues, cooling pipes, coins, bronze coins, hardware, the bronze medal that is also made up of bronze. Some other alloys of copper, gunmetal, copper and tin. Copper and tin was also bronze. I think gunmetal has got something else also. So this information is not accurate. Please let me know in the group what gunmetal is made up of, which metals, okay, with the percentage. Then it is used for making gun barrels, castings, bearings, etc. Castings and bearings are used in machines, parts of machine parts. Bell metal, again 80% uh, copper and 20% tin, okay, used for making bells, gangs, etc. Gangs, again, it's a machine part. A constant tan, 60% copper, 40% nickel, used for making electrical apparatus. German silver, copper, zinc, nickel, 60, 20, 20%, used for making silverware, utensils, and for electroplating. It may be noted that German silver does not contain silver, okay? Don't be confused. Alloying of gold. Now, this is very interesting. See, pure gold is very soft and cannot be used as such for jewelry. Therefore, it is generally alloyed with other metals, commonly copper or silver, to make it harder and modify its color. The purity of gold is expressed as carats. You must have heard about 22 carats, 24 carats. What is that? Pure gold is 24 carat. 24 carat means out of 24 parts, 24 ratios of gold. This gold contains 24, exact 24, 100% gold. 18 carats gold means it contains 18 parts of gold, 18 ratio of gold, and other 6 ratio of other substance. So the percentage of gold in 18 karat gold is 18 divided by 24. 18 is parts of gold, ratio of gold, upon total parts in the ratio, that is 24 multiplied by 100. So that is 75%. Purity of 18 karat gold is 75%. What is the purity of 22 karat gold? Calculate that. 22 upon 24 into 100. You will find the answer. Okay. So I think the chapter is over with these questions, and yes, now we are not left with anything else. Now I know that some students exams are coming up, and we have to finish triangles chapter as well. Now we have finished with this chapter, metals and non-metals, completely. So 3 chapters of chemistry are done, and I think physics we have done with 2 chapters. We have to do one more to complete 3 chapters of physics as well. That we will do, but now we have to focus on mathematics. I think we have to finish now 2 huge chapters. And one of it is really huge, that is triangles, and then coordinate geometry. After I complete triangles and coordinate geometry, then I will move to physics chapter 3. Then again I will move to maths, and then after finishing most of the syllabus of maths, we'll focus on physics and chemistry again. So that's the plan. Now I'm going to assign you the homework, I want you to complete the homework and submit it to me in the live class. See, I don't want to disturb you now because you will be having your tests, online tests, which are going on right now with me. So you focus on that, study for that. When your tests are over very soon, I'm going to keep a live class and discuss all the doubts of this particular chapter. Till then, you just finish the homework and submit me. Okay, so I'll see you very soon in the next class. Till then, bye bye.